Okay, so finally we are doing the last question of this section B and the last question for this examination video. Okay, so question number 9. This question has the maximum mark of the 16 points, and there are 4 questions in total. Okay, so first information: a farmer is growing a field of the wheat plants. The height age of each plant can be modeled by a normal distribution. So finally, we got the distribution question. That means this is a topic 4 question with the mean and standard deviation, right? So it is known that P of H less than 94.6 is equal to 0.288, and the P of H greater than 98.1 is 0.434. And then question A, we need to find the probability that the height of the randomly selected plant is between 94.6 centimeter and 98.1 centimeter. So we do know that the P of H less than 94.6 is same as 0.288. P of H greater than 98.1 is same as 0.434. Okay, so question A, we have to calculate the probability of H between 94.6 and 98.1, right? So let's draw a distribution graph. Okay, and I'm going to say this is like that, and I have mean here, or we can just say that this is the 94.6 mark, and this line here marks the 98.1. Okay, and from the information we know that this part here is same as 0.434, and also this part here is same as 0.288, and we are trying to calculate this part here. Okay, then we know that everything under the distribution is actually adds up to 1. So we can do probability that 94.6 is less than H, or H is less than 98.1 is same as 1 minus 0.288 minus 0.434. Then we get the answer of 0.278. Okay, and that's the answer. Okay, then let's try the question B. We need to find the value of the mean and standard deviation. So means we have to do the z-testing. Okay, so using the information that we have, P of H less than 94.6 is equal to 0.288. P H value greater than 98.1 to 0.434. We're going to find the standard deviation and mean value. Okay, so for the first part, since we need to find the 2 unknown variables, we have to find so since we need to find the 2 unknown variables, we have to set 2 equations. Okay, so for the first part, we're going to use the inverse norm to calculate or to set the z equation. Okay, so for the first part, we're going to use inverse norm to calculate the z value. So I'm going to set area as 0.288, mean value as 0, standard deviation as 1. And for the second part, since this is H has greater value, we have to change that into the less than, so we can calculate the z value. Okay, so we're going to do pH less than 98.1 equals 1 minus 0.434, which is equals to 0.591. Then we can say that the area is equal to 0.591, mean is equal to 0, and the standard deviation is equal to 1. Okay, then using the z-testing, let's try to use GDC together. So we're going to go second distribution, right? And then you're going to go inverse norm. and you're going to set 0.288 comma 0 comma 1, then you get z value equal to negative 0.559239, and then you can set z equation. So we know that z equation is same as zx minus mean over standard deviation. So we're going to go negative 0.559236 equals to x, which is the 94.6 minus mean over standard deviation. So we got the equation number 1. Right, then for the second part, you can set it as we have to subtract 0.434 from 1, right? Then we will get 0.566, and we have to set, when we are using the inverse norm, we have to set the area as 0.566 and the mean value as 0, standard deviation 1. Then we get z value equals to 0.166199, right? Then we can set our z equation as 0.166199 equals to 98.1 minus mean over standard deviation. Okay, from this point, everything is very straightforward. What we need to do is we have to first have to expand our equation, right? Times standard deviation equals to 94.6 minus mean. 0.166199 times standard deviation equals 98.1 minus mean, and we either substitute one to the other side, or we can set this as a mean value equals to, I'm just setting everything equals to mean, right? So mean value is equal to negative 0. Or the, we can say 94.6 plus 0.559236 standard deviation, and mean is equal to 98.1 minus 0.166199 standard deviation. Then we set these two equations equals to each other and solve for the mean, which is same as 97.3, and standard deviation is same as 4.82. Then let's try the question number 6. We have extra information here. So the farmer measures the 100 randomly selected plants. Any plant with a height greater than 98.1 centimeter is considered ready to be harvested, and height of the plants are independent of each other. So question C has two baby questions, and these are the actually binomial distribution questions. Okay, to satisfy binomial distribution, there we have to meet the three requirements, right? So to satisfy the binomial distribution, first requirement that we have to meet is the fixed number of the independent trials. The second requirement is only two outcomes, or we can say have outcomes of pass or fail, right? Or the requirement number 3 is the probability of the success is the same for every trial. And this question number C, and the information actually meets all these three requirements. So we can say that this is a binomial distribution question, okay? So question CI, we're going to use P of H greater than 98.1 equals 0.434 again. And then we're going to let K equals the number of plant harvest. Okay, so we're going to say P of K is equal to 34, and because that's what we are aiming for, and we're going to use the binomial distribution. Don't forget, when you do this type of question, you always have to use this format to identify that this question is binomial distribution, right? So for this question, x is binomial 100, probability 0.434, and using binom PDF from your calculator, we're going to substitute all these numbers. Then you get the probability of k equals to 34 as 0.0133198. So it's approximately equals to 0.0133. Okay, then let's look at the question C, II. And given that the fewer than 49 plants are ready to harvest, find the probability that exactly 34 plants are ready to harvest. Okay, so this is like kind of conditional probability combined with the binom CDF, right? So we're going to do question II. We're going to find the k is equal to 34 given that the probability of k is less than 49. Okay, so we're going to do probability of k is equal to 34 over probability that k is less than 49. Okay, so we're first going to calculate this part. Probability of k is less than 49. Okay, so this means probability of k is less than 49 is actually same as probability is equal to less than or equal to 48, right? So we're going to use for this case a binom CDF from your calculator. Okay, so we're going to use binom CDF and we're going to set it as 100, probability 0.409, and number 48. Then you get P of k less than or equal to 48 as 0.84218. Then we can calculate the probability as using the number from the previous question, 0.0133198 over 0.84218. Then we get the value of 0.0157033. So we can calculate that the probability of k value is equal to 34, or the probability that exactly 34 plants are ready to harvest when there are 49 plants to be ready is equals to 0.0157. Then let's try the question number D. We have another information. So in another field, the farmer is growing the same variety of wheat but is using different fertilizer. The heights of this plant F are normally distributed with the mean 98.6 and standard deviation D. The farmer finds the interquartile range to be 4.82. So we're going to use the interquartile range to calculate the D value. Okay, so we can say that our Q1 is happening here, Q3 is happening, and Q2 is our mean, right? And it's equal to 98.6. Then since interquartile range is 4.82, from here to here is same as 2.41. From here to here is same as 4.41. Then our Q1 value is same as 98.6 minus 2.41, which is equals to 96.19. And then the Q3 value is same as 98.6 plus 2.41. So our Q3 value is same as 101.01, right? So these are the information that we have already. Then we know that D is a standard deviation value. So means we're going to set the probability and you're going to use inverse norm to calculate our standard deviation. So now we're going to set the probability. Okay, so probability of 98.6 minus 2.41. I'm just going to write this, right? And is equal to 0.5. Why is 0.5? Because we know that from Q1 to Q2 is 25%, Q2 to Q3 is another 25%. And if we are considering this under the distribution, right, let's say this is distribution, right, then this is actually the 50% of that probability 1, right? So we can set it equal to 0.5, okay? Then we do know that we can set inverse norm, or we can use the inverse norm to set the Z equation for each side, right? For the left hand side, we can say 96.19 minus 98.6 over standard deviation is equal to Z, right? For the second part, we can say that 101.01 minus 98.6 over standard deviation is equal to Z, okay? Doesn't matter which side you're using, but we can say the area is equal to 0.5, mean is equal to 0, standard deviation is equal to 1, and using inverse norm, we can calculate the left side Z value as negative 0.674481, right? For the right hand side, we can calculate the Z value as 0.67448. That means using this Z value and one of the equation that we already set, we can calculate the standard deviation value. So 101.01 minus 98.6 over standard deviation is equal to 0.67448. Then we can set the 2.41 over 0.67448. Then we can say this is equals to standard deviation, and standard deviation is actually equals to D value. Then standard deviation that we have calculated is same as 3.57307. So we can calculate the D value as 3.57. So we have completed this examinations paper.